Hello, it's Crypto Mux right here, and in this lesson I'll be showing you some basic SSRF, which SSRF is server-side request forgery. Now, this is a server-side issue and web applications, and how you actually find it is it's pretty kind of hard but pretty simple. Now, what you're trying to look for is any type of URL that is fetching content from another site or another domain, so to speak. So when you find that, you can actually break through the firewall and get into some of the local internal services. So let's get started straight away, and I'll be using Portswigger for these examples because they have a nice little lab there you can practice on. And yeah, let's get started, fellas. Okay, so let's get started, So we are going to do about 4 server-side requests for forgery practice labs. So this is going to get you prepared to find real-life SSRF vulnerabilities in web applications. Now, server-side request forgery is obviously a server-side issue. It is very, very well known, and it's found a lot of domains, a lot of places it's found. And it's very hard to circumvent and mitigate. So that's why it's so bad, and it's so easy to find and so easy to make a mistake to fixing it. So I'm gonna let you know that first thing we need to learn is how to exploit it and what it is properly. So it says here that server-side request forgery, also known as SSRF, is a web security vulnerability that allows an attacker to induce the server-side application to make HTTP requests to an arbitrary domain of the attacker's choosing. And it says that the attacker might cause the server to make a connection back to itself. And what this is a picture of what it looks like. So this hacker is us. We're actually ethical hackers test out websites we've got permission to. So we find that there's an SSRF vulnerability in a parameter or URL or something. It's actually fetching content from a different domain. Then what we do is we basically find a third-party system, obviously the domain, it's the parameter that's referencing the third-party domain. And what we do is we put in, say, something like HTTP 127.0.0.1 or some sort of internal IP. And it will break through the firewall, the internal system will make a connection back to itself, and it will give us some of the information on the back in the internal system. And the impact is really high because it can lead to arbitrary command injection. Which arbitrary command injection, also known as remote code execution, is the highest tier of bugs on any bug bounty platform. You will get paid, if you find one, probably 30k or 40k, depending on what the website offers. And they're probably one of the bugs we should all be looking for. The first practice we're going to do is this one here. So let's open up that one. It says the lab has a stock check feature which fetches data from an internal system. So we're going to have to delete the user Carlos. So let's load that practice lab. And let's copy this into Firefox. I've got Burp opened here. So let's it's set in a check stock. So we need to find something that checks the stock. Let's go to view details. And let's turn on our interception proxy and check the stock. And as you can see here, it's fetching content from a third-party application, and it's a totally different website. So what you'll do is you'll use Burp Collaborator initially, and you go, okay, can we actually get a connection back? And what you do is you do this, and if it actually we'll send to the repeater. If Burp actually gets something back, it is vulnerable. So poll now, and it's vulnerable. It got a connection back, so it's vulnerable. We got a response from the collaborator. So it's told us to connect to an internal service. So the one we want to connect to is 127.0.0. Oh no, so 127.0.0.1 and admin. And what you would find now is it will induce that it will induce the application to make that HTTP request and connect to an internal internal service or internal server. And as you can see here, we've accessed the admin panel. And if you just, like right there, it's access to admin panel. You forward that off, and you find it now the admin panel is down there. Now it told us to delete the user Carlos. So let's turn on the proxy again. Let's intercept that request and then go 127.0.0.1 admin. And we found that if you highlight that, we'll see that admin delete is the path we need to type in. So I want to go delete, and it was just 1 minute. It was actually that, and then it was delete username Carlos. Fire that off, and the exercise should be complete. Beautiful, we did it. All right, back to so the next one now. Next one is it's going to be one that we have to find the IP. So we have to do some basic brute forcing and find the IP, the internal IP. So it attacks against other backend systems. Let's access that lab, and it says that we need to find this X. This is the last digit of the IP, and this is what it should be connected. What we should use to connect back on. So when I did this one, I found out that you have to actually find a 404. If you find a 404 error in the intruder, because we're going to send it to intruder to brute force that last digit, and if you find a 404, that's usually a good sign that we've found an SSRF and it's actually the right IP. So it's a few details. Again, we have to go to stock check. Let's use that. Intercept the request, check stock, and we just send this to the decoder. Decode that link there. We'll send it to the repeater. We'll paste that in, and then we'll send that last digit to the intruder. Well, we can go to the intruder, and what we'll do is we'll go to payloads, or actually positions, and it said that last digit. So we're going to add that, and we'll use a simple numbers payload, and we'll go from 1 to 50 with one step. So increment by 1. We'll start that attack, and we're looking for 404s. Remember, we're looking for 404s as a status code. I think the IP was 21. No, it's not this time, so it's changed. Nice. It's actually changed this time. This is really cool. It must change every time you load this session. Load this lab. Looking for a 404 somewhere. Okay, let's increase it to 80, and we'll change the threads to 200. Start that. Oops, I started like 3 of them then. Do it again. We'll just get out of all these ones because there's a lot of intruders going on. 404 somewhere. Where are you, 404? There should be a 404 somewhere. Let's actually sort out by 4. Nah, we've just got a 4. 400. Missing parameter. Is that same lab? Just wait. Let's have a look to what lab this is. We think it might have a different one. Yeah, that's the right one. And yeah, okay, so we've done it right. Let's see if we actually set the position right. Yeah, we set the position right. And it did say that was the right IP. Yes, okay, so doing everything right, we just need to find the right range, the last digits. Let's say 200. Let's try that. We won't use code. Let's try that this time. We'll flip by 404s. Just wait back, kick back, and relax. I should see our 404 soon. Nah, let's try it again. Try it again. We've got a 50. We've got a 500. Let's send this to the repeater. This could be a good sign. Just wait. No. Okay. Let's send this to the repeater again. And let's clear that and make this the variable. Get out that intruder attack. Get numbers and one. I should do 0 to 100. Steps 1. And we'll do 100 threads. See if this works this time. No. It says missing parameter. Let's capture this request again because I think there's a missing parameter somewhere. Oh, do you know what? We had to actually encode this. That's the reason why. Okay, so intruder. Yeah, that was the reason why we had to actually. I forgot all about this. We actually had to encode this one. So we add this as the variable. What we'll do is we'll just put admin at the very end because that's what we need to connect back to. We'll then do payloads, numbers, and then we'll do 1 to say 30, or 30 will do fine, and then increment by 1, and then say 100 threads, and we're looking for the 404s. Remember, 404s is the one we're looking for. So sort by those, and we should find that we get a 404 soon. Try it again. But we'll increase the range to like 100. Okay. Let's try this one more time. It is a little bit tricky, this one, because it's actually something that's you have to play around with it a bit. Hopefully we get it this time. Four fours we're looking for. We'll get this. We'll get this. Don't worry. Let's send this to the repeater and see what we get back. We should get a 200 OK. Yes, we did. Send to intruder again. We're looking for that 404. All we're looking for is that 404. And I never knew it was going to be this tricky. And we will get it because I've done this before. Try 500 this time. It's funny because last time I did this, I pretty much got it straight away. Now it's like it's not even finding it. It's really strange, but we will find it eventually. There we go. It's on 206 this time. It's just totally random. Alright, so let's send this to the repeater. And obviously we need to go admin. 206 this time. Now we should get him into the back end. Perfect, we got the same response. Then want to go delete username Carlos and kaboom, we've completed the lesson. Success. Now what we did for the end, I should say up there, success. Now what we had to do with this one is we had to brute force that end digit of the IP and access a different backend system and then delete the user color. So it was a tricky one. Now the next one is even more trickier. It's basically an open redirect that leads to SSRF. So let's do that one. So this next one we have to, which is this one here, we have to find an open redirect. We need to take note of this IP here. Let's put that on the lab material. Now we actually have to find an open redirect, and then basically find the open redirect and redirect to one of the internal services. This one is probably a harder one, but it's easy when you get used to it, the gist of it. So let's again, the stock API, the check stock, we know that's vulnerable to SSRF. We know that's the vulnerable SSRF link. So let's just, or button. So let's just find an open redirect. And I think with this one, open redirect is in the path parameter. If I just type in evil.com, the location should reflect evil.com, and that means it will redirect to that site. Boom. Let's go HTTP. Remember this IP. We want to redirect to that IP there. So we'll put that in, and then we want to copy this whole path, and then we'll paste it into the vulnerable SSRF one. So we'll just check stock and paste that path into there. Now remember, we have to euro encode this here, so let's paste that in and euro encode it. Doesn't work when you don't euro encode it. Boom. Now we want to send that to the repeater and see what we get back from the response. And we should find that we are exploited. Boom, we've actually exploited it. We've got access to the internal service. Now let's delete the user Carlos. So delete username Carlos. You know, encode that. Repeater. Boom. And we should see in the response that it says success. We actually deleted the user Carlos. Pull that off. Boom. That's a very basic one. Is it going to do it now or not? Let's do that again. Maybe it just takes a long time to actually send it off. Let's just do that again and actually work carefully. Okay, that didn't work. Maybe it's just the way I structured the delete user username. Okay, yep, that worked. Send that to the repeater. Send it there. And put it off. Success. It said success, so we've actually deleted the user Carlos, but it's not saying it has. It has completed it. Path. Yep, we did that right. We pasted that in. Let's just try and do the admin panel again. Let's see if that works. Something's going on here. It says success, but we haven't. It doesn't. Maybe it could be bug of the website. Who knows? Let's just do this. Should come up with the admin panel. Yep, it did. And then we just basically did delete. Oh, it's already been, the user's already been deleted, so it's obviously already been completed. Yeah, so could have been an issue with the site, but we deleted user Carlos. Now the next one we want to do is probably one of the less common ones, and it's actually an XXE, which is external entity injection that leads to SSRF. I'm not going to go through what XSE is now. That's something in another chapter, another video, sorry. It's external entity injection. It's when you've got an XML parser that's not properly sanitized and programmed properly. It's got issues. And then we can actually read files and access local files. So this one here, this one says, obviously, the check stock API has XML issues. The lab server is running a simulated EC2 metadata endpoint at the default URL, which is on this IP, which is a typical EC2 instance IP, metadata IP. The endpoint can be used to retrieve data about this instance, some of which might be sensitive, and then we have to try and access the IAM secret. Let's access this lab. This one was probably my favorite one, actually. I kind of got excited when I accessed the EC2 instance. Let's go that. Now, what we need to do is, again, we need to go to any of these products and check the stock. check the stock. And as you can see here, it's XML this time. Now, I know how to program this one. So what we need to do is we need to create a doc type. Actually, it needs to be in this format. Doc type. We'll just call it doc and then put that. Then we need to create an entity, and it's going to be called XSE, and we're going to execute a system. And what we might do is just read the etc parsewd file first, just to see if it works. XML format will be just put in XML, and we want to basically call that, call it DTD, something like that. We'll press go, and we'll actually find that we can read the parsewd file. Perfect. Because the XML parser is improperly sanitized and it's got issues. But now what we want to do is access that EC2 instance, this IP here. So instead of file command, we just want to type in that. There was a little trick here because there was a little thing that you could actually look at. When it says invalid product IP, we just need to append that to the end of the path, and it will tell us the next one. It was a really cool trick I found. So now next one, it will be a different one, and we just simply append that one there. Tells us what we need to put in the path, which is pretty cool. And next one will be something different, IAM. And then I think it was the next one was security credentials. And then I think it was admin. And that's when it retrieved the IAM credentials, the secret credentials. Oops. What have I done? Yeah, that's the XML parsing issue. Okay, so here we go. As you can see here, boom, we've actually got EC2 instance credentials, access key ID, secret access key, token. Now from here onwards, we can grab this information and access that EC2 instance, that server. Internally. So this is running in an internal system. You don't get to see that on the client side. It's running in the network, in the internal network, and we can access their server just through these credentials. Awesome. So that was about it for SSRF. If you found any of these bugs in a real life application, report them straight away with a proof of concept. If you're doing bug bounties, write up a report, boom, you're going to get a 30k bounty or whatever. I hope you liked this video. Please like, comment and subscribe, and if you have any troubles, comment down below and I'll reply back ASAP about how to help you with doing the labs. Yeah, so I hope you enjoyed this video. Give me a thumbs up. This is basically can be applied in real life bug bounties. And it's great. It's good fun. SSRF is obviously the most common vulnerabilities these days. There's still a lot of research being involved, and it's going to be great. I hope you get a SSRF vulnerability in bug bounties, and cheers, catch you later, enjoy the rest of your day or night, and cheers, see you in the next video.